Okay, so today I'm going to work on getting the cutting table that I built last week attached to the surface here. In order to do that, I'm using threaded inserts in the 3/4 inch melamine surface. And real quick, I just wanted to show you guys the three types of inserts that I've found. First, over here, we've got these two inserts here. These are made for going into hardwoods, okay? As you can see, they've got really fine threads that go completely around the barrel of the connector, and these are machined, they're not cast, okay? These two happen to be number for 8x32 screws. This one can be inserted with a flat tip screwdriver, and this one is inserted with a hex wrench. This is the type that I'm going to be using today. This is a 1/4x20 insert that goes into a 5/16 hole. This is designed to be flush mounted, so I'm going to countersink each hole just a little bit to get this lip at or below the surface, because I don't want this lifting up or causing any level issues with the bed itself. And with that, I'm going to go ahead and start getting my holes drilled. Okay, so because this is kind of difficult for me to film as far as being able to place the camera, I'm only going to show you guys 2 holes worth of drilling and inserting and inserting, etc. And then we'll kind of skip ahead from there. So here we go. First up are the 5/16 holes for the inserts. And as you can see, I didn't drill all the way through on a couple of those, or on one of them, because it hit the under surface, or the support, and that's fine, because these inserts are not long enough to go all the way through anyway. And I really got to be careful about policing up my drill debris, because anything gets under the work surface, it's going to fiddle with the level, and I suspect I'm going to have enough problems with that anyway. So I'm going to countersink each one of these just a little bit. Just to give the lip on the insert someplace to go. That looks pretty good. Now, instead of using a hex key to put them in, I'm going to cheat. If you're not cheating, you're not trying, right? I typically put a little bit of glue on these. I don't really know how practical or necessary it is, but I feel better. And I don't think it's going to hurt anything. Boy, cold glue does not like to go anywhere. Piece of paper towel to clean that glue off. And just a little bit deeper to go. That is probably as good as that one's going to get. I need to countersink the other one just a little bit more. So let's go ahead and do that. There we go, that's a lot better. The swarf out of the way. Wow, I managed to not get glue all over the table when that happened. I need to buy a lottery ticket. And that is the goal I was after. I wanted to countersink just a little bit. You know, I'm going to pull this one out. And we'll bump him just a little bit, get him deeper. There we go. 2 well countersunk 1/4x20 inserts. And just to show you, yeah, they do work. Ta-da! Okay, so I'm gonna go do the other 6 of these holes and I'll be back. Okay, so I kind of skipped ahead without intending to, and I got all of the bolts installed, and the cutting surface is now firmly bolted to the base of the machine with 4 2.5-inch 1/4-inch bolts on each side. So now it's time to start truing up the machine itself, and we're going to do that by setting up these little end stop switch targets here. And what I'm going to do is I'm going to adjust all the targets so they're in equal distance from each end of the axis support. And then we'll go ahead and start seeing if we can't get some square drawings out of this thing. Okay, what I'm doing is I've cut a block that's the same width as the distance from the back of that switch target to the green bracket that you see there. And what I'm going to do is I'm going to use that wood block as a gauge to space the remaining switch targets an equal distance from the framework. That is done in order to make the G28 auto squaring routine operate properly. Now we're going to check this side. Got a little arrow here. So that's just a little bit different. So what we're going to do is we're going to move this 1 notch ahead of where it is. And check that again. Oof. It's a little bit different. It's about 1 millimeter off, but unfortunately my teeth on these belts are about 2 millimeters. So I actually need to move half that distance. And I don't know if I can do that. Yeah, it doesn't look like it. Okay, so this is my Y1 switch. So we're gonna have to remember, or write down somewhere, that this differs and it's uncorrectable by moving the block. Okay, so let's move over to the other side. Okay, this is the X0 motor, thus the X0 switch. So let's see here where we're at. And again, I've got to move the block again, so try just a little bit differently this time. And again, we're about 1 millimeter off, so I'll note that down. And let's move around and check our Y0 motor, which I think we've already done, but might as well, right? So let's grab my little calibrated block here and see where we're at. Yeah, this is where we started. That's dead on. And that is our Y0. So we're going to call that a 0 offset. And we're going to rotate just a little bit to catch the, what are we doing? X1 motor and its switch. Get this out of the way and move the camera. Oh yeah, we're a little bit off there. So again, I'll hold it in place and pop this off. So it looks like, yeah, I'm about 1 millimeter off on the X1 as well. Okay, now it's time to start the first auto square and see where it gets us. Unfortunately, due to some audio and video problems, I no longer have the footage that shows the complete squaring of the carriages. All I have is this little bit here that shows it coming to the home position. It does square, but it's not something you can easily see from this video. And there you go, all squared up and set to the 0 home position except the Z-axis. Okay, now let's move on to getting my plotter fixture set up so we can check the squareness of the machine. Okay, to do the drawing test in the MPCNC machine, I'm going to use the plotter pen attachment that I got from my shop about 12 years ago. This is actually kind of a clever design. It uses a rubber thread protector to cover the pen, and it's just 2 brass tubes that slide inside one another. It uses a Sharpie micro pen on one end and a little weight, and it just comes apart like so. Kind of, maybe. There we go. And it uses the Sharpie micro pen. Unfortunately, they don't make these anymore. I discovered that yesterday when I was looking for replacements. This one's all dried up, unfortunately, but I've got a blue one that's not dried up. So I will at least be able to run the test today. So the cool thing about this is that it's got a couple of brass tubes that ride inside of one another, and they're swagged just a little bit on the ends. You can see there that they're just a little bit curved in. And the idea being is that they'll slide easily up to a certain point, but then stop, okay? And the reason for that is that it allows you to have an uneven or imprecise Z0 surface and still be able to use the pen without applying too much force. Essentially what you do is you'll assemble it and then set your Z0 point, okay? So that it's just pushing the pen a little bit up, and then, you know, raise it so it doesn't touch at all. And no matter what, it'll just ride in there and have a reasonable amount of pressure on the pen tip. If you make one of these, I don't recommend using this as a cap. It does not make a perfect seal and it will dry out. So that being said, let's go ahead and get this mounted up in the MPCNC machine and see how it draws. Okay, so in theory, we're going to go ahead and draw 2 squares. One that's 50 by 50 and one that is 100 by 100. And then we'll measure those. So let's go ahead and get a pen loaded. And let's see how we do. Stick the pen in here. The pen holder here that I printed is not meant for for that size at all. So, and I should be 5 millimeters high on that, so I'm going to bounce that down just a little bit and then reset my Z0 point. So let's go down 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter. And are we touching it? We are. Okay, so That's a good Z0 point right there. So let's back that off. Actually, we'll back that forward one. Do a G92 Z0 to reset that. And then do a G0 Z5 to get it off the paper. Okay, so now we're going to try to run this file and see what happens. It's commanding the Z-axis up to 20 millimeters. This is the default setup for Gerbil using the toolpath generator that I used. And there we go. That's a 50. And that's a 100. That was kind of strange. I don't know why it did what it did there as far as this dumb little line here. But I suspect that was my fault in how I generated the toolpath. So let's go ahead and get the gantry out of the way and do some measuring and see where I get, or see what I get. Okay, so we have got our two squares. Let's go ahead and see how we did on squaring the machine. So what we're going to do here is we're going to measure diagonally across. And we get about 71 millimeters that way. And let's check to make sure that our line length is correct. And it is. It's right on 50 millimeters, which is what that square is supposed to be. And let's go ahead and measure again. I got to do it this side, right? Yeah. It's been a long day already. So, and that is about 71 millimeters there. So we've got a perfectly square here. And let's make sure that our length is correct here. And we are at exactly 100 millimeters. And we should get right around 142. And that's what we get. So we got 142 that way. And 142 that way. So we have a perfectly square machine. And I'm very happy and impressed because normally it's not that easy. So I think what I'll do next is come up with another G-code program to do some more interesting shapes and maybe some lettering and things like that, just to check out and see how the machine functions. Okay, let's do a text font test. This is just G-code that has been toolpath is all. Let's go. Load it. And of course the windsurf's knocking my door around. There's even a little shade in this print. Not print. Well, yeah, it's kind of print, but it's a CNC job. The toolpathing was done on Aspire version 9.5. And I was using the Gerbil post-processor. And there we go. And throwing a little shade at Caleb because I can. Next up, let's do this, but instead of 12mm high letters, let's do 50mm high and see what we get. So my text was too big this time. Or my paper wasn't wide enough. This is what it is, I guess. And there we go. I probably can't get all of that into the frame. No, but hey, here's what it is, right? Okay, folks, this pretty much ties out the build of this machine. I've got a couple of the things I need to do, but for the most part, this is it. I would appreciate it if you'd subscribe and like this video and subscribe to the channel. And no, I can't talk right. It is what it is. This channel is pretty much about stuff I enjoy doing, and it's all over the map. So I have no idea what the next video is going to be about. But if you're into similar things that I am, you might like it. Anyway, again, like and subscribe, and I'll see you folks later. Thanks for watching.